This video covers Trig Notes 5.1. The topic today is going to be exponential functions. So let's first take a look at what an exponential function is. Here's an example of one, where you have a function that's being raised to some power, obviously the exponent there, and the exponent has a variable in it. So you'll see here it says exponent is a variable, and the base is a positive number that's not equal to 1. So the first concept we're going to talk about is how do you actually solve exponential equations. So if I have something like this, 10 raised to the 1 minus x is equal to 10 to the 4th. If the bases are the same, you're going to set the exponents equal to each other. So in this case, bases the same, set exponents equal. So because the base in both sides of my problem is a 10, I can just set the exponents equal to each other. So in this case, to solve it, I would have to move over the 1. I get negative x equals negative 3, positive 3, sorry. And then I have to get rid of the negative in front by dividing by negative 1. So I would get x equals negative 3. Plug that back in and check it. 1 minus negative 3 is 4, and that's what I wanted the exponent to be. So again, when the bases are the same, set the exponents equal to each other. That's the concept that we are going to be working with. Again, that's listed up here as well. Well, what if they're not the same? In this case, the base is a 2, and this base is a 16. Well, what I know is that I can get to a 16 by doing 2 raised to some power. So I could write 16 as 2 raised to the 4th power. So now my problem looks like this. Bases, which are both 2, are the same, set the exponents equal to each other. So move over the 3 by adding it. This time I would get x equals 7. So plugging the 7 into here, 7 minus 3 is 4. Is 2 to the 4th power 16? Yes. So I get my answer that way. Okay, for the next problem, I have 1/5 raised to the x plus 1 equals 125. 1/5 is the base, and 125 is the base. Well, here's what I know. I know that 5 raised to the 3rd power is the same as 125. I would like, instead of my base being a 5, I would like it to try to be a 1/5. So what I can do is, if I know that 5 raised to the positive 3rd power is 125, I know 1 over 5 raised to the negative 3rd power should also be 1 over 25. And so now I would be able to write this as 1/5 raised to the x plus 1 equals 1/5 raised to the negative 3. And now I can set my exponents equal to each other. So I would end up getting x equals negative 4. Again, check this. If I put a negative 4 in there, I get 1/5 raised to the negative 3rd. Punch in your calculator 1/5 raised to the negative 3rd. Do you get 125? You do. So that would be my answer for this one. Okay, next problem, I've got 2 raised to the x power equals negative